Percentages. This video will cover from basic percentages through to the more advanced reverse percentage and compound interest. First of all, just a quick reminder of the equivalence between fractions, decimals and percentages. When you have a percentage, remember that that means out of 100. So 50% literally means 50 out of 100, which in its simplest form would cancel down to 1/2. In order to change a percentage into a decimal, just divide it by 100. So 50 divided by 100 is 0.5. To change a decimal into a percentage, times it by 100. So 0.3 times 100 is 30%. To change it into a fraction, you can either, if you know your tenths, hundredths, thousandths column, you could go straight to 3/10 because the 3 is in the tenths column, or you could do your percentage first and go to 30/100 and then cancel that down to your 3/10. For a decimal such as 1/8, to change that into a percentage or into a decimal, what you would want to do is remember that the line in the fraction means divide, so that literally means 1 divided by 8. Now, because that won't go in evenly, you need to add some zeros after your 1. 8 doesn't go into 1, put your decimal point, carry the 1. It goes into 10 once, with 2 left over. It goes into 20 2 times, with 4 left over. It goes into 45 times. So that's my decimal, 0.125. And remember to go from a decimal to a percentage times by 100. So 12.5%. Finding a percentage of a quantity. If we start with getting 16% of 60, you have two methods that you can use. I'm going to recommend one of the methods, but very quickly, the first method would be to get 1% of 60. Now, if 60 is the full amount, then 60 is equal to 100%. Divide by 100 to get 1%, which then would be 0.6. Once you know 1%, you can get any percentage you want by timesing by whatever number you want to get. So 0.6 times 16. That gives me a value of 9.6. So that's option 1. That will work for every example. Divide by 100 to get 1% and then times by your percentage. Alternatively, and what I would encourage you to do, is if you're trying to get a percentage of a quantity, if you write the percentage as a decimal, which I showed you in the previous slide, then that is what's called your multiplier. And all you need to do is multiply your quantity by the decimal and it will give you the answer. So 16% as a decimal is 0.16. So to get 16% of 60, I would do 60 times 0.16, which again would give me my 9.6. The second method is better for whenever we come to the later examples. That will certainly speed us up. So to get 12.5% of 80, if you want to, maybe pause the video here and try that one yourself. Okay, so you may have used method 1 or you may have used method 2. As I said, I would encourage method 2. If you used method 1, you'll have found 1% by dividing by 100, so getting 0.8. And then you'd have found 12.5% by timesing 0.8 by 12.5, which gives you a value of 10. If you wanted to do method 2, which I would encourage, you would see that 12.5% as a decimal divided by 100 is 0.125. Now remember, dividing by 100 is simply moving your decimal point back 2 places. And then you would do your amount 80 times your multiplier, which is 0.125, and that will give you your same answer of 10. Okay, finding a quantity as a percentage. So there are 600 children in a school, 72 of them are left-handed. What percentage is this? What you're going to do is put the amount of the group, so in this case 72, over the total amount, in this case 600, and times it by 100. So in other words, to find a quantity as a percentage, you're going to write it as a fraction, the group amount out of the total amount, and then times it by 100. Now, if it is non-calculator, obviously what you would want to do is really cancel that down as far as you can. Now, 72 divided by 600 would cancel down to 3 over 25. And if I then times that by 100, or remember, if you're timesing by 100, that's the same thing as 100 over 1. So you could cancel on the diagonal here, 1 and 4, which means you're doing 3 times 4 over 1 times 1. So the answer is 12%. If it was a non-calculator, if it was a calculator question, you could just type that sum directly into your calculator. Okay, looking at the next example. So again, if you want to pause and then try this one yourself, and then I'll continue. So we now have 4 faulty light bulbs out of 80 times 100 out of 1. Cancel your 4 out of 80, that's going to cancel to 1 out of 20 times 100 out of 1. I can cancel my 20 to 1 and my 100 to 5. That's given me 1 times 5 over 1 times 1, so 5%. Hopefully you got that correct. Okay, finding the percentage change. So what we have here is when something has changed by a certain amount and we want to know what the actual percentage was. Now you have a formula here which you need to use, and that formula is change, the amount of the change, over the original amount times 100. So the amount of the change over the original amount times 100. Now, if we look at this example, so a coat normally costing £60 is on sale for 48. What is the percentage change? Now, the amount that it's changed by is £12 because it's gone from 60 down to 48, so that's a £12 decrease. We do that over the original amount. Now, the original amount was the 60. It normally costs 60. And I times that by my 100. Cancel that down as much as you can. 12 over 60 is 1 over 5 times 100 over 1. 5 and 100 cancel to 1 and 20, so we get 20 over 1, so 20%. And you should finish off by saying that that's a 20% decrease. So as well as giving the actual percentage, you should say whether it's gone up or gone down. Okay, if you want to then pause and try this example, and then I'll continue on. Okay, so what is the actual change here? Well, her salary has gone from 25,000 up to 26,500, so that's a change of £1,500. We put that over the original amount. Now, her original salary before the increase was 25,000. And we're going to multiply that by, remember, 100, which is essentially 100 over 1. Now let's cancel down as much as we can here. We can get rid of 2 zeros for both of those. And then dividing by 5, we can get the 15 down to 3 and the 250 down to 50. Just dividing by 5 there. Timesing that by 100 over 1. Cancel on the diagonal here. 50 goes to 1, 100 goes to 2, and that means I'm doing 3 times 2 over 1 times 1. So that's a 6% increase in pay. Okay, increasing or decreasing by a percentage. Now this is why I encouraged the multiplier method earlier, because that now means that this becomes easier to do. So starting with increasing 150 by 13%. Option 1, which is the way I wouldn't recommend, is to get 1%. So divide by 100, so 1.5. Get 13%. So 1.5 times 13. Which is 19.5. And then add that on. So 150 plus the 13%. So that's your first option, but that isn't the way I would really recommend doing this question. I would recommend that you do it with the multiplier method. Now, if you're increasing by 100%, that means that you're starting with, if you're increasing by 13%, you're starting with the full amount, which is 100%. You're adding 13% on. That means that you're ending up with 113% of the full amount. So basically, I want to find out what is 113% of the full amount. Now, how did I find out what a percentage of an amount was? I got the multiplier by changing the percentage into a decimal. And you do that by dividing by 100, so 113% is 1.13. I then multiplied my quantity by that, so 1.13 times 150, and that gives me my 169.5 straight away. Now, this multiplier method is going to be extremely handy in the examples to come, and it is definitely the best way to do it. Now, when you're getting your multiplier, it is so easy, and you're going to see a nice pattern here. So if I'm increasing, now this is only for an increase I'm about to do at the minute. Say you were increasing something by 12%, your multiplier is 1.12. If you increased by 22%, it's 1.22. If you increased by 68%, it's 1.68. If you increase by 20%, it's 1.20. If you increase by 3%, it's 1.03. So you can see your multiplier is extremely easy to work out. Increase by 99%, 1.99. So when you're increasing by a percentage, all you have to do is multiply by 1 point what that percentage was. And that's the easiest way to do these questions. So if you want to just take a second and let's try increasing 650 by 18%. So pause the video and try that. So 18%, what we said is the multiplier is 1 point the percentage. So 650 times 1.18. All we do then is go to your calculator and work that out, and that is 767. So hopefully you got that correct. Now this method does work very well for a calculator one. If it is a non-calculator, you may prefer the original method. You may find that a bit easier to do in a non-calculator paper, but certainly for a calculator one, I would encourage the multiplier method. Now, when you're decreasing, you follow the same basic method, but it's not going to be 1 point anymore, because the 1 point came from it being over 100% because we were increasing. Now if we're decreasing, it's not going to be over 100%, it's going to be under 100%. So if you start with 100% and you then decrease that by 15%, that leaves you with 85%. That means I'm trying to find 85% of 90. So 85% as a multiplier would be 0.85. So I would do 90 times 0.85, and that is 76.5. So when you're decreasing, it's not as simple as 1 point the percentage. What you have to do is in your head basically take the percentage in decimal form away from 1. So for instance, decrease of 15% is 0.85, a decrease of 7% is 0.93, a decrease of 30% is 0.7, a decrease of 65% is 0.35, and so on. Now, if you want to pause and try yourself decreasing 165 by 12%. Okay, so hopefully you've been able to work out that a decrease of 12% means you're taking 12 away from 100, which is 88, so it's going to be 0.88. So we're doing 165 times 0.88, which is 145.2. Remember, in the same way as we did above, you could of course find what 12% is by dividing by 100 to get 1%, times it by 12, and then taking it away from 165. But again, I would certainly encourage the multiplier method here. Okay, reverse percentages. A lot of students tend to find reverse percentages quite difficult. Not so much because what you do is difficult, but because they fail to spot that it is a reverse percentage. Now, a reverse percentage has a key word in it. And that key word is original. So reverse percentages are about finding the original price. So they're telling you that something has happened, it's been increased or decreased, the new price is such and such, what was it before I did the increase or the decrease? Now, when you're doing a reverse percentage, again, two options, and let me quickly run you through both options, but there's going to be, again, the one that I'll recommend. What you could do is realise that if it's been decreased by 15%, then you started with 100%. You took 15% off. Which left you with 85%. So the amount that you have there, the £102, that is actually 85% of the original amount. Now, if that's 85%, if I divide by 85, that will tell me what 1% is. 1% is going to be 1.2. So dividing by 85 gives me 1%. If I then multiply by 100, that tells me what 100% is, which is what I'm looking for. That's the full amount. So that is your first option. But the key is to realise that is not the same thing as increasing 102 by 15%. You can try that if you want to see, but if you did 102 increased by 15%, you would get 117.30. You would get a different answer. And that's because it was 15% of the original price that was taken off. And if you then just try to increase by 15%, you would be increasing by 15% of the new price, which is not the same as 15% of the original price. So you need to work out what is the new price equal to as a percentage. So £102 is equal to 85%. Divide by that to get 1%. Times by 100 to get 100%. So that is your option 1. Option 2, which is the one that I would encourage, is if you work out, again, think about your multipliers. A decrease of 15% is a multiplier of 0.85. Now, normally what we did was we multiplied by that. So if I wanted to work out, well, how do I take 15% off something, I would multiply by 0.85. This is a reverse percentage where that's already been done, and what we want to do is get back to the answer. So if normally you multiply, what do you do in the reverse of that? You divide. So you do 102 divided by your multiplier this time, divided by 0.85, and that will just give you straight away your £120. Please remember that if something is money, you should give your answer as money with a pound sign. Now, second example, if you want to then try this one yourself and then play the video to hear the solution. Okay, so this time it's been a pay rise of 12%, so it's been an increase of 12%. That means that the multiplier is 1.12. It's a reverse percentage, which I know because I want to find my salary before the pay rise, so I want the original salary. With a reverse percentage, you don't times by the multiplier, you divide. So you're going to do 33,600 divided by 1.12. And if you do that, that gives you your answer of £30,000. So then that's going to be your final answer. Okay, final thing is compound interest or repeated percentage change. Now, this can take a lot of different forms. And basically this is when you have a percentage that is repeating itself. Now, if it is in terms of just literally interest in a bank account, they will tell you that it is compound interest as opposed to simple interest. But this question can take other forms, and I've given you a couple of other forms here. So the first example, a car loses 8% of its value every year. Now think about that sensibly. That does not mean that you work out 8% the first year and then keep taking it away. Because if it's losing 8% of its value every year, then that means in the second year it loses 8% of its current value. In the third year it loses 8% of its current value. Well, its current value is changing each year because it's decreased. So the 8% is going to change every year. So if a car loses 8% of its value every year, again, you've got two methods. We're going to do both methods here so that you can see. Now, method one. Work out then, if it's £6,000 at the start, so at the beginning, £6,000, if it loses 8% of its value, that's a decrease of 8%, that's a multiplier of 0.92. So at the end of the first year, you do 6,000 times 0.92. That tells you that the value is 5,520. So that's what it is at the end of the first year. How much will it lose then in the second year? Well, its value is only 5,520 now. And again, that needs to decrease by 8%. So I times by 0.92 again. That brings the value down now to £5,078.40. So now at the end of year 2, that's the value. I have one more year, which means it's going to decrease again by 8%. So I take my current value, my £5,078.40, I times that by 0.92, and I get 4672.128. Now, obviously it's a money question, so I give that correctly as money, which means that I can only give two decimal places. So normal rounding rules, £4,672.13. Now you can see that there's a fair bit of work in that. And what if it wasn't 3 years? What if it was 10 years? That would be quite time consuming. So let's look at a simpler method. Instead of doing that, what you can do, very, very, very easy method. Take your original amount, times it by your multiplier, which in this case is 0.92, because remember it's a 8% decrease. And put that to the power of the number of years. So in this case, 3. If you type that in, one sum into your calculator, 6,000 times 0.92 to the power of 3, you get out straight away 4,672.128. And again, remember, you would give that correctly as money. So basically, instead of all this working out, I can do this one sum, this one thing to type into my calculator. And that is obviously a lot simpler to do. Now, what your formula is here, what I've actually done, is basically your original amount times your multiplier, which is what I've been referring to from the start of this video. That's the percentage basically as a decimal. So if it's an increase, it would be 1 point something. If it's a decrease, it would be 0 point something. And that's to the power of the period of time. That is your formula. That is a very important and useful formula. And I would definitely recommend that would be the method that you would use, because that will be quite useful to you. Now, if we consider another example, so we'll just move all of that extra information out of the way, keeping our formula at the top there. So if I look at this example, so this one is just a compound interest example. So this is kind of your most standard and probably your easiest one. I place £2,500 in a high interest bank account. It pays 6% compound interest a year. Now, interest is you gaining money. That means the bank is paying you, so it's an increase. So 6% increase is 1.06 as a multiplier. Do that to the period of time, which is 4. So I do 2,500 times 1.06 to the power of 4, and that gives me 3,156.1924. Give that as money, 3,156.19. Easy. So original amount times the multiplier. Remember, if that's an increase, it's 1 point the percentage. If it's a decrease, you're taking the percentage away from 100 and writing it as a decimal to the power of the period of time. Okay, final example. A species of plant is increasing its population by 3% every month. If there are 500 plants in an area at the beginning of February, how many will there be at the end of July? Now, I've actually just realised that I've used an increase again here and I haven't actually done a decrease yet, so let's just change that. Okay, so a species of plant is decreasing its population by 3% every month. So you've got 500 plants at the start. If it's decreasing by 3%, take 3% away from 100, 97%. So the multiplier is 0.97. And then it's to the power of the time. Now let's think about this very carefully. It's 500 plants in an area at the beginning of February. How many will there be at the end of July? So we have the beginning of February, but the end of July. So that means I have all of February, all of March, April, May, June, and all of July. So that's actually 6 months, not 5, because I've gone from the start of one to the end of the other. So that was over 5 months. And I then get my calculator. 500 times 0.97 to the power of 5 equals 429.36. in this case, it has to be a whole number because it's how many plants are left. I would always round down here. I'm not rounding down just because it's a 0.3. I'm rounding down because when we're talking about how many plants are actually left, as soon as there's less than 430, so even if it was 429.8, as soon as there's less than 430, you don't have that last plant anymore. So you can't have part of a plant. So once it decreases from 430, you would automatically give your answer as 429.